Hi, everyone. For those of you who have not worked with me yet, my name is Johnnie Stupek. I am the head debate coach at the University of Georgia, and I am here with you this morning to talk about some of the environmental and economic features and dynamics of the Arctic. So why are we taking this time to talk about the Arctic environment? Well, for one, the environment of the Arctic is incredibly important in and of itself. As we'll cover in just a little bit, the icy features of the Arctic terrain are critically important in regulating both the carbon cycle as well as the amount of solar energy that ultimately gets absorbed by the ocean and integrated into sea temperature. And anytime we talk about the environment of the Arctic, we should remember that there are people that live there. There are about 4 million people that call the Arctic their home. Many of them are from indigenous Inuit communities, and they've inhabited the Arctic for thousands and thousands and thousands of years. And the changes to their Arctic ecosystems fundamentally changes their way of life in a pretty fundamental way. Second, the Arctic contains a variety of natural resources that are highly sought after by industrialized nations like the United States, like Russia. So chief amongst these natural resources, of course, is oil and natural gas. The United States Geological Survey believes that the Arctic is the largest unexplored oil reserve that remains on planet Earth. So the official position of the United States government is that this is where much of the oil that we have not yet been able to exploit and extract exists. And it's not just fossil fuels that are sought after in the Arctic, but it is also minerals like lithium and cobalt, which are critical components of batteries that we make, rare earth elements, which are also important features of modern technology, of modern military technology. Those exist in the Arctic, and there is intense competition amongst the industrialized Arctic nations to get a hold of those resources. And the third reason that we're talking about the environment today is that it really is almost impossible to really, wrap your head around the geopolitical and geostrategic environment in the Arctic if we don't think about the way that the environment and changes to the environment change those dynamics. When you read about this stuff, you'll probably see arguments along the lines of melting sea ice opening up new lanes for military ships, for commercial ships. You'll probably read about melting sea ice opening up new lanes for the ability of these nations to reach resources, to drill new oil wells and natural gas pipelines, etc. But the changing environment can also, affect the infrastructure that currently exists in the Arctic, be that commercial infrastructure or military infrastructure. And so it has a hugely influential dynamic on the way that countries interact with each other. So what is it that makes the Arctic ecosystem, that makes the Arctic environment really unique? Well, for one, a lot of it's frozen, right? The Arctic and the Antarctic are two of the areas of the world where we have most of the Earth's cryosphere. And cryosphere is a word for the frozen parts of the Earth, right? The ice, the glaciers, the snow, all of that comprises the cryosphere. And so we're going to talk a lot today about the Arctic cryosphere, its dynamics, and why it matters for the climate and for the ecosystem. The Arctic also has fairly unique lighting conditions by virtue of being at the very top of the Earth, right? So you see the northern lights up there. There are days in the Arctic where you can see the sun at midnight. There are also days in the Arctic where you never ever see the sun. So it's a very, very unique environment and ecosystem for people and for the various wildlife and biodiversity that lives there. And so this is a graphic depiction of the hydrological cycle of the Arctic. What does it look like? And I want to show this graph not so much to talk about the hydrological cycle and water runoff, although those are important issues, but I kind of want to talk about the different features of the Arctic environment and the Arctic ecosystem that you're probably going to read about, and hopefully use that as a visual way to explain why some of these things are pretty important. And so a lot of the Arctic is sea ice over ocean. So the North Pole is a layer of sea ice, and under that ice is the ocean. Okay, so a lot of it is ocean that is simply covered by a sheet of sea ice. Permafrost, when I first read about permafrost in debate, I just sort of thought about it as like, oh, well, that's the ice that's always there. What permafrost is it's in the ground. So permafrost is areas of the soil and the ground that stay below freezing, okay, so below 0 degrees Celsius, 32 degrees Fahrenheit, for at least 2 consecutive years. That's the technical scientific definition of permafrost. Areas of the ground that stay below the freezing point of water for over 2 years consecutively. And now that technical definition might make it seem like a lot of this permafrost is new, but a lot of it is incredibly, incredibly old. The scientific estimates are the oldest permafrost is over 700,000 years old. So this stuff has been frozen for a long, long, long time. And what you will see, and this kind of demonstrates it, is that the permafrost is under the topsoil, okay? So there's a layer of soil above the permafrost that scientists call the active layer, okay? And the active layer is not permanently frozen. So the active layer will thaw during the summer. We'll have a brief period of vegetation, and then it will refreeze. Active layer. And so, from a carbon cycle perspective, this is what I think is maybe the most important for understanding how these dynamics work and operate in debate. For a long, long time, permafrost, okay, this permanently frozen area of the ground has been a way of storing and sequestering carbon in the ground, away from the atmosphere. And that happens through 2 dynamics. So one, when permafrost is created, it freezes over carbon matter, it freezes over the organic carbon, plants, animals, what have you. And the second dynamic is that as the active layer thaws and refreezes, it typically pushes down the carbon in the active layer into the permafrost area. And so for most of the Earth's history, the Arctic and the permafrost area has acted as a sink for storing carbon, a place where carbon comes and is stored. Okay, I want to use this, and these numbers are not like today accurate, but I want to use it to demonstrate just how much carbon is in the permafrost, because it's a lot. So this graph says there's about 850 gigatons, I believe the current number is about 900 gigatons of carbon dioxide, of CO2, that's in the Earth's atmosphere. Okay, and we're continuing to add to that year by year, and this kind of lists the way some of the other features of the carbon cycle work and operate. but the important part to understand is that there's about 1,400 gigatons of carbon dioxide sitting in the permafrost, trapped in there. And so there is really almost double the amount of total carbon dioxide in the atmosphere that's in the permafrost. That is a lot of carbon dioxide, right? Okay. Second thing that I want to talk about, and this relates to the other icy features of the Arctic that are on the surface. Okay, so sea ice, glaciers, snow. And this is the idea of albedo. What is albedo? At a basic level, albedo is a measure of how reflective a surface is in terms of sunlight. So you can measure the albedo. The albedo, usually spits out a quantified number of some sort. You can measure the albedo of a rock, of a piece of soil, of the ocean, of ice. And it just so turns out that ice has a very high albedo. It is highly reflective of sunlight back to the atmosphere. Water, unobstructed by ice, so the ocean itself has a very low albedo. So when solar radiation, when sunlight hits the ocean surface, nearly 90%, 93% of that is absorbed by the ocean itself. A very small percentage of that is reflected back. But nearly 93% is absorbed by the ocean itself. When sunlight hits snow and ice, only 15% of that is absorbed. And nearly 85% of that is reflected back. Okay? So beyond just the carbon cycle dynamics, we have an additional dynamic with albedo, where the sea ice and the cryosphere of the Arctic plays a large role in regulating temperature and climate, okay, by preventing too much solar radiation and sunlight from being absorbed by the ocean. And so I want you all to understand the dynamics of the way permafrost operates, the way albedo works, because when we start talking about this next part and how climate change is affecting the Arctic, I think that this will hopefully, in a more detailed way, demonstrate what we mean by a feedback effect, right? And what we mean by what happens when these dynamics are changed by a decrease in the amount of sea ice or ice. Okay, so to start it, as you all probably know, the Earth is getting warmer. The Earth's getting warmer pretty quickly. It is getting warmer much faster in the Arctic in the 21st century than it is in other parts of the globe. The Arctic itself has risen about 3 degrees. The average annual temperature has risen about 3 degrees since 1971. As you can see from this graph, the Arctic temperature increase is happening much faster than the global average, especially in these areas around Canada, Greenland, and Alaska. And so these temperature increases are changing the Arctic environment and the Arctic ecosystem in a pretty fundamental way. okay? So the ice is melting. The sea ice is melting at an astronomically fast rate. So the number that the Arctic Council gives is that we are losing 5,000 metric tons of sea ice a second. So this cryosphere is declining by a fairly substantial percentage each year. Well, what does this mean? It means that there are a number of feedback effects and follow-on effects on our climate. Okay? What happens when the permafrost itself starts to get warm enough that it thaws? Anyone want to take a guess? Yeah.
It releases carbon.
Absolutely. It releases all of this carbon that's been sequestered there into the atmosphere. And it gets worse. Because when you put carbon dioxide, when you put CO2 into an incredibly low oxygen environment, okay, you freeze it for thousands of years in this permafrost. It typically turns into a byproduct of methane, CH4. And methane tends to be, it is also a greenhouse gas that can have a much more profound effect on warming. It creates a stronger greenhouse effect, okay? So it's not just carbon dioxide and CO2 that's released by the permafrost, it's also methane. And this methane can be incredibly, incredibly dangerous in terms of the pace of warming. What happens to albedo when sea ice melts? Yeah.
The ocean absorbs more sunlight.
The ocean absorbs more sunlight. The ocean eats the carbon, and it heats the ocean, which can cause more sea ice melt, but it also changes the ecosystem of the ocean in a pretty fundamental way, okay? Just like the Arctic is warming faster than the global average, the Arctic Ocean is acidifying quite a bit faster than the national average. And so when the Arctic Ocean has to eat all of that solar radiation that previously was reflected back by sea ice and snow, it changes the environment of the ocean itself, which can be really dangerous for the wildlife there.
Can you explain how that causes acidification?
Can I explain how it causes acidification? Yeah, so basically the ocean tries to stay at a relatively, neutral-ish pH, and when you have a lot of sunlight and radiation, it directly upsets that pH balance and turns it a little bit more acidic. And that can just be harmful for the wildlife that lives there in the ocean. The other element of this that I was interested to learn about is the Arctic is experiencing a lot of wildfires. You don't think of the Arctic as an area that's going to have a bunch of wildfires, but they do, and there's a lot of forest area in some of these tundra regions. And so, that can be incredibly devastating for a lot of things, right? For the indigenous people who live there, for the infrastructure that is there for mineral extraction, right? What happens when you have raging wildfires in a region that was previously covered by sea ice and snow for much of the year? And the other element of this is that the land and sea-based wildlife, they struggle to live. Polar bears could not live in the Chos, It would be a tough environment for them. These animals have adapted over the years to live in a frozen ecosystem, right? And to operate in and around sea ice and in and around the ocean ecosystem. The other element of sea ice melt that we typically talk about when we talk about kind of broader warming impacts in debate is sea level rise and coastal erosion. Okay, and so there are estimates that nearly 10% of the water on Earth is frozen in this Arctic cryosphere. And so when that melts and gets released into the ocean, you have an increase in the sea level. And this can erode coastal communities, and it can really change the dynamics of people who live in coastal regions, not just in the Arctic, but literally everywhere. Questions about warming components? All right. Well, what can be done about it? What are some entities that try to do some things about it? So obviously, if we were to try to address this fundamental issue of climate change, ideally we would want to make some changes to the way that fossil fuels are consumed or the way that carbon dioxide is released by industrialized countries. The topic kind of doesn't give us the flexibility to do that, so we have to think about what are some Arctic specific interventions that we can create, and what are some ways that we can do that. And we'll talk about that in a little bit. I want to just start a little bit, because BK kind of teased this yesterday, about Arctic governance and the entities that are involved in operating in the Arctic. So at a basic level, we've got 8 countries that have territorial claims in the Arctic, and they all sit on this thing, the Arctic Council, which is comprised of the 8 member states with territorial claims in the Arctic, as well as about 6 representative indigenous peoples organizations that sit on this council, as well as observer nations who have an interest in the way that the processes of the Arctic play out. The Arctic Council is a framework for cooperation on Arctic issues. So it is a place where Arctic nations meet to talk about how they're going to address issues that are unique to the Arctic and that are important for the Arctic ecosystem itself. So the hiccup that the Arctic Council ran into. So the Arctic Council is structured in a way that there is a rotating chair. Okay, so one country operates as the chair of the Arctic Council for a 2-year period, and it rotates amongst the 8 member states. Okay, so the United States is the chair, you come to Alaska, and that's where we're gonna have our meeting. Okay, Norway's the chair, you come to Oslo, etc. Well, in 2022, it was Russia's turn to be the chair. So Russia was the chair of the Arctic Council, and then Russia invaded Ukraine. And the response of the other 7 members of the Arctic Council was to say, look, we think that Russia has violated a fundamental premise of international law and a fundamental premise of the way that we operate and interact with one another. And so we are not going to go to Russia for the Arctic Council meeting. We will not meet with you to talk about Arctic issues. And so there was serious doubt about the capacity for the Arctic Council to operate in the future. Okay. And for about a year, the Arctic 7, so pick out Russia, met. But things kind of died down a little bit in terms of the tensions from the Arctic Council's perspective. Russia handed over their chair to Norway, which chaired the Arctic Council for the last 2 years. It's now going to be turned over to Denmark. But they continue to meet. They continue to issue reports on environmental damage to the Arctic, on the effect of climate change on indigenous communities. They continue to talk about the potential for cooperative frameworks for action, but obviously there is a fair amount of tension amongst these member states. Okay, the United States has issued some verbal threats about annexing or buying Greenland. Right, these countries are still a little bit threatened by Russia's aggression. And so the capacity for cooperation has decreased fairly substantially, but there's still this framework in place. They still meet with one another to talk about cooperative issues of the Arctic. Well, we've talked a lot about climate change and its effect on the Arctic ecosystem, its effect on the environment. And the reality is that industrialized countries are taking this as an opportunity to develop and extract more fossil fuels in the Arctic. And this is the gold rush. So, as I mentioned before, the geological government agencies in the United States government believe fairly strongly that the Arctic is a large unexplored oil reserve, right? And so you can see just how large some of these geographic areas that we think are these purple and blue areas that we believe are unexplored oil and gas reserves. And as the ice melts and the ecosystem thaws, we are using more and more resources to try to exploit some of those oil reserves and drill more, okay? There is both onshore and offshore drilling capabilities in the Arctic about oil and gas reserves. One element of drilling that I think is a little interesting is, you remember how we talked about the permafrost being a permanent feature under the ground, under the topsoil, right? And so the permafrost, in some ways, has been a foundation of the development of infrastructure in the Arctic. You build on a stable surface, right? The ground is frozen solid. And so in a world of permafrost melt, you change the ecosystem, or you change the ground, literally the ground, on which some of these pieces of oil extraction equipment are built on, right? And so there is going to be a change, or there will have to be a change, in the way that that infrastructure is created if you have a world where the permafrost is melting, because that's literally the ground, right, releasing and becoming less frozen solid. And so it's going to change the way that roads operate. It's going to change the way that transportation and infrastructure is built, because it's the ground upon which all of that stuff is built. Questions? Yeah.
With melting permafrost, or generally, let me bring this question. Since like in some places the oil seems really remote, like or like northern part of Alaska or Yukon territory, or like northern Russia.
Yeah.
How, if there is, how widespread is, like, people are saying it's not worth it to try mining there?
Sorry, can you rephrase the last part of that?
Are there concerns among like oil drilling companies or governments about trying to actually get the oil, or like getting it to a refinery, and then it might be not worth it to try and mine in the Arctic?
Yes, well, they are incorporating an element of what does transportation cost look like, and that is related to the question of what does transportation infrastructure look like, right? So how are we developing roadways? They actually try to extend the icy season, because that's the basis of the roadways and the travel that happens in the Arctic region. And so there's an assessment that those companies make about transportation infrastructure and transportation costs when they're thinking about a question like, how do we get this raw material to a refinery to turn it into petroleum product, right? It's like, it's all a cost calculus for them. Yeah.
How does drilling with the permafrost work? Like, if it's thawed, would it be easier to drill or harder?
Well, you can't drill into permafrost as permafrost. You can drill into the ground after thawing, right? And so potentially thawed permafrost would, when we say there's a lot of carbon, that also includes, carbon turns into petroleum, right? So there is a possibility that you get more oil available in a world of permafrost thaw, but you also, upset the infrastructure dynamics in a pretty fundamental way. Any other questions about that stuff?
Before going and drilling into these different locations, do if the United States, for example, wanted to go and drill to be able to get oil from a certain place, do they have to go and consult with the Arctic Council, or would they just have to go to the reservation of plain land that they call them?
So usually they can just go if they have a territorial claim. If it's in Alaska, right, if it's in United States territory or in their exclusive economic zone, right, off our outer continental shelf, then they'll just go there and they'll drill. And they don't really have to ask. There's not a dynamic that forces them to. All right. One of the other economic dynamics that, well, just to hold back just a little bit, one thing you will hear, or one thing you will read when you read articles about Arctic thaw and climate change is you will see people talk about this idea of Arctic greening. So the idea that when the land thaws, when there's less ice on the land, there is a greater capacity for vegetation and for plants to grow there, which is all true. And the argument that some folks make is that, plants, they perform photosynthesis, they can remove carbon from the atmosphere. So some folks think that this might potentially balance out with some of the feedback dynamics that we talked about. And so there's not nothing to this notion that Arctic cryosphere thaw will cause more plant growth, but the environment itself gets upset in a lot of different ways. And so when we think about the dynamics of wildfires, for example, wildfires can release this thing, black carbon, into the atmosphere, okay, which is a really dangerous form of carbon. That can then turn into precipitation dynamics that are not favorable to plant growth. And so there absolutely is an argument out there about the increase in arable land and vegetation in the Arctic as a result of warming, but I would like to encourage you when you think about these issues to think about all of the different environmental factors that are at play in any one of those questions. The other super important economic factor of the Arctic is, BK talked a lot yesterday about some of the military choke points and the routes that military vessels might take in the Arctic. Well, it's not just military vessels that travel through some of these sea lanes in the Arctic, it's also commercial shipping vessels, right? So vessels that are conducting trade from nation to nation, or even just trade down the coastline, they might use the Arctic as a way to navigate to their trading routes, okay? And so, again, in some ways, melting ice can potentially open up new lanes or wider lanes for commercial ships to go through. It might potentially increase the mobility and navigability of the Arctic itself. But it can also lead to some environmental conditions that might not be favorable for commercial shipping operations. So there are these things, these Arctic cyclones, right? These are kind of what happens when you put a hurricane in the Arctic, basically. They're pretty dangerous weather events that you will see, again, happening in greater number and greater magnitude in a world of global warming. Those can be dangerous for commercial shipping operations. Navigating through ice itself, okay, is always a little bit of a dangerous proposition because there's a potential for accidents to happen. And so commercial shipping is a very important economic element of all of this stuff. And additionally, the question of icebreakers, right? This is on a lot of folks' minds when we're thinking about this topic. These are ships that are meant to break apart the ice that the military of the United States and Russia uses. Those icebreakers can facilitate lanes and routes for the military. They can also facilitate lanes and routes for commercial ships. Questions? All right, let's talk a little bit about what some of the affirmative cases are that might potentially be in the area of the Arctic environment and economic dynamics in the Arctic. And so, common propositions related to how to address Arctic warming and Arctic climate change. Again, the most fundamental one relies on the notion of trying to do mitigation, but that's obviously a little bit outside the scope of topicality on this topic. And so another thing that people recommend is they recommend trying to do adaptation work. What do I mean by adaptation? I mean climate strategies that are designed to help communities increase their resilience to the changes in their environment that climate change will bring on. And so oftentimes, because of the way warming is talked about in debate, we think about adaptation as the oppositional strategy to mitigation, because we like to think about things in terms of trade-offs. But in most climate literature, adaptation is a complementary strategy to mitigation. And so when you read some of these Arctic Council reports, you will see a lot of talk about trying to create adaptive measures for Arctic people to become more resilient to and survive better in the Arctic. The other recommendation that you will see often is to, especially as it relates to questions of adaptation, is you will see a lot of literature suggesting we should do more, industrialized nations should do more to talk to and get the input from indigenous communities about how their environment and how their local resources are affected by climate change. And so how can these Arctic Council countries engage with indigenous communities to talk about what happens to their home and how their home has changed a little bit? So various monitoring efforts have been proposed. Okay, so using sensing data, using satellites to look at the effects of climate change on the Arctic, to look at the effects of sea ice melt, to monitor the intensity of wildfires. Okay, that's a big one that's talked about. Policies to look at and try to manage some of the ocean acidification dynamics that are there. Okay, all of those policies are out there. What about on the economic side, the natural resources side? Well, there are, one, on the kind of fossil fuel side, right? There are folks who think we should use the Arctic as an area for enhanced drilling capacity and enhanced exploitation capacity of these Arctic resources. We should drill more, right? We should get more oil and natural gas from the Arctic environment. There are lots of proposals around trying to use the Arctic as a way to find some of those mineral resources that I talked about at the open. Okay, so lithium, cobalt, rare earth elements. There are your sort of basic precious metals are in the Arctic as well, gold, silver, zinc, things like that. So there are certainly proposals to get at those resources. a variety of proposals are out there to try to regulate and improve the commercial shipping network, both in how do we open up lanes for commercial ships, how do we allow our commercial ships to operate safely alongside the commercial ships of our adversaries in the Arctic region and in these choke points we talked a little bit about yesterday. And then there are some proposals about search and rescue missions, right? How can the military support the capacity for these commercial ships to deal with what happens in the event that a disaster were to happen or an accident were to happen in the Arctic. So there are a lot of different proposals that are designed to get at some of these environmental and economic dynamics. Other questions?
How do you explain like why punching is coming fast and like when you're like a newer profession at Central, like how do you size and like the time for development?
Is the question how do you balance time frame with solvency, or just how do you explain why it's a faster impact than their?
Yeah, that like equivalent to health impact.
Yeah, so I think that there are two ways to explain this. So one, it's that even if the sort of existential risk elements of climate change might not happen today, some of the feedback loop dynamics that will make those existential risks inevitable might happen very, very soon, right? So if we're right, about some of these feedback dynamics, right? The continued warming decreases albedo, leads to permafrost thaw, all of those things, then we might get to a point where these feedback loop dynamics go past our capacity to mitigate or stop them, right? And so the things that make existential risks happen, those tipping points might happen very, very quickly. The second way to do this is to talk about what happens, how warming changes the civilizational and societal dynamics that we operate in, right? And so if you're debating a team with like an economy impact, for example, and they're going for economic recessions are much faster than global warming, it's like, well, perhaps, but global warming and natural disasters and sea level rise destroying critical infrastructure, like it's going to be pretty bad for the economy. And so winning a warming turns their impact argument combined with this tipping points time frame argument, I think is sort of the way that you want to do it. And it's also talk about this in lab, but like the way that you want to think about impact comparison is it's not all about we have to win time frame. It's like, we can win, but probability is a more important frame for thinking about impacts than time frame, and we have some reasons why we access this time frame idea. Yeah.
How do the Arctic Council working groups interact? It's like if the app was something about a biodiversity impact.
Yeah.
How would like the process of implementing that policy be part of the working group or have to go through that in some way?
It's interesting. So I think that there's fertile ground for the affirmative side to make some arguments that what they do is have the U.S. implement something within an Arctic Council framework, right? So the Arctic Council creates a cooperative framework that exists in the status quo, and potentially some of the changes that an affirmative case could do are in the direction of how does the United States implement or, kind of go in the direction of whatever this Arctic Council policy or working group is. I think it's up for debate, right? Because there's not, there aren't a lot of cards that are saying U.S. doing this unilaterally is a Arctic Council thing. But there's, I think, ample and fertile ground that we ought to explore at least about how the app can operate within a cooperative framework even as a unilateral policy.
Sort of building off of that, does that mean the easiest way to go about having the affirmative affect the entirety of the Arctic, if it's like conservation methods, would that be done then through that sort of multilateral framework?
I think that there's a multilateral framework that exists, and the way I kind of talk to my lab about this, there's a lot of, in the Arctic, there are a lot of these kind of, and you'll see this in a bunch of multilateral settings, there are agreements to talk about what to do, right? So there's a cooperative framework that says we're gonna meet every year as the Arctic Council, and we're gonna write a little report that says here are all the problems in the Arctic, and here are some things we think we might be able to do, and we'll set up these working groups to cooperate. And so you have a setting where it's a lot of bureaucratic talk and often not a lot of action that follows on to that. And so I think that, there are a couple approaches, right? So you could have an affirmative say, we don't really care about this Arctic Council thing. We think that it's doing nothing good and the US needs to act alone. I think that's a route, and then there's another route that sort of says the Arctic Council is a cooperative framework that exists in the status quo, and the app can kind of turn that cooperative framework into something that produces a little bit more action and substantive policy.
Okay.
Yeah.
Why is Arctic adaptation used to global adaptation?
I don't know that it is. I think that when the authors talk about Arctic adaptation, I think they are fairly concretely talking about how can we adapt for Arctic communities? Like, how can we adapt the infrastructure in the Arctic and the infrastructure of indigenous communities to climate change? So my read of the people that are talking about this issue, and again, I'm not like super deep in adaptation questions, but my read is when they're talking about Arctic adaptation, they're literally just talking about that. How do we adapt this environment for the people that live there? It's not about creating a global model of adaptation that then everybody learns from, but it's how do we make this ecosystem somewhat more resilient to some of these climatic effects that we're seeing.